Hello again. At the topic of solving absolute value equations, in today's video I'm gonna explain how to solve the equations like this. I will rewrite it later on. And the second equation we will be solving is like this: x plus 2 in absolute value minus absolute value of x is equal to 0. Okay, so that you know what the topic or what the video will be about. So let's start with the first equation, and this is it. So this is our let's say like fourth equation we are solving in this topic. As we said during our first video, we can have a look or understand this equation like this is f of x is equal g of x. Like we are looking for x's when these two functions are equal to. So let's solve it graphically first. It would mean, and it means that our function f of x is represented by the equation y equals absolute value of x take away 3, and our function g of x in this case is represented by the equation y equals x plus 1. This is good to realize because now you are able to sketch the graphs of these two functions and find or look for their intercepts. As we already know, we are able really to sketch the graphs of both functions by using the translation or transformation. This means that our parent function is shifted 3 units to the right. So this is our y and x axis. Here is 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4. I don't know which numbers will I need. And 1, 2, 3, 4, 5, and let's have 6 here. So the first graph is gonna be sketched like this. Okay, it doesn't look pretty, but okay, this line is not very good. As you already know, these two lines are symmetric with the respect of the axis of symmetry, which is the parallel line with the y-axis and passes through the point 3. So this is our first function, y equals x take away 3 in the absolute value, which is easy to sketch. And you are also able to sketch the graph of the function g of x. And just to repeat, this is our parent function, y equals x. We don't need it, and we already know that this function is moved or shifted by 1 unit up, and then the graph of this function must pass through the points 0, 1 and negative 1 and 0. So this is the graph of the function y equals x plus 1. As you can see, there is no absolute value in our second function or function g. That's why the function really has the values with the negative numbers. And as you can see, in this case there is only one intercept, which is here, and if you really sketch the graph like precisely, you will see that these intercepts coordinates are 1 and y is equal to number 2. So we found the solution graphically. Now let's have a look how is it gonna be solved algebraically, and you will see, and here I will explain the point from the previous video that you really have to keep in mind and have a look backwards. If your solution is really from the interval you are calculating the equation on. So what is the definition of, as we have only one absolute value expression in our equation, we just need to transfer or translate this only for this absolute value. So it means there will be, as you already know from the topic of sketching or graphing the absolute value functions 0 point. That's why we think and we need to find out when the absolute value x minus 3 is equal to x minus 3, or in case the expression or the value of the expression is negative number, is represented by the expression minus x plus 3. And the first case, this one, is if and only if x is greater or equal to 3, and the second is happening if and only if x is less than 3. Okay, so this is how we calculate the absolute values, but you are quite familiar with this one while we were drawing or sketching the graphs of piecewise functions. Now it would mean, and you again read all the information for this step from above, it means if x is from the interval, okay, it must be closed, 3 to the infinity, then our equation will become like this: x minus 3 is equal x plus 1. Please denote or note that on this interval our g of x is x plus 1, and it will remain the same for the second interval. If I don't forget, I will stress this again. Now, if you solve this equation, you will see that the solution is negative 3 is equal to 1. Basically, what does it say? It is like false statement, and it would mean that the set of our solutions, and I will like denote it k1 because we are solving like on the first interval, is empty set. And this is something which you should understand, that this is okay, because if you would have a look on the graphs of these two functions, and I forget to write here that this is number 3, so we are now solving the equation on interval from 3 to the infinity, which means that we take in mind only these two lines. The first line is this one, okay, and the second line, if you would sketch the graph, or where the point 3, where the value of 3 for g of x is, then you realize that this is the graph of our function we take in mind. And as you can see on this graphical representation, and of course you can see it from the definition of the functions or equations of these functions, that these two lines are parallel, so it means they will never intercept, okay, because this line can be represented by the equation, and if it would go further, by the equation y equals x minus 3, it would basically intercept my y-axis in negative 3, but the blue or dotted line is not anymore representing the function y equals the absolute value of x minus 3. That's why we take only the orange part of this line, and as you can see, the slope of this function is the same as the slope of the g of x function, and that's why the lines are really parallel and will never intercept. So the conclusion for this interval, x being greater or equal to 3, is empty set. Okay, now let's have a look what will happen on the other side, or on the side to the left from point 3, which is that for each x from the interval from the negative infinity to 3, our function or our equation will be represented by the equation, and you get the information from here: negative x plus 3 is equal to x plus 1. And if you solve this equation, then it's gonna be negative x is equal to negative 2, because what did we do here is we just take away x and we take away 3. Now if we multiply both sides of the equation by negative 1, then it's gonna be 2x is equal to, and when we multiply 1 over 2, x is equal to 1, which is basically the solution, and this is the second case, and we have to really make the difference between these two sets. We just put there the small lower index 2, and it is one element set which consists from number 1. So this is the solution, and yeah, I think that's all. And to find like the final solution, to define the whole set above the whole domain of the function, you would simply do the union of these two sets, which basically is again only set which consists, or one element set of number 1. Okay, so this is our solution. Very good. What else should be said here is maybe I'll highlight the results here. Okay, now let's have a look on the last example, and then you will have all the information to be able to solve any kind of absolute value equation, I guess, also graphically, but also algebraically. So our next equation looks as I wrote, and it's like the 5th example. Absolute value of x plus 2 take away absolute value of x is equal to 0. Now, here is one tricky thing, and there is a reason why I wrote this equation like this, because to solve this equation graphically, it's like, let's say, hard to sketch the graph of the function on the left side of our equation, because then it would be like piecewise function, and to sketch this it takes, let's say, a lot of time. But if you realize that you can rearrange this equation like this, then it's gonna be really easier. If you want to, you can try this one, when basically you'll sketch the function f of x is equal to absolute value x plus 2 take away absolute value of x, and then the second function will be g of x is equal to 0. So basically here you are looking for the intercept, and I'm not sure if it's gonna be like 1, 2 or more with the x-axis, okay? But as you will see, to solve this equation graphically, this one, the easier way is to solve this equation, but it is always but it is again, or it is of course the same equation in manner of in point of view of the solutions. Okay, so as we already know, our first function f of x is defined on the left side of the equation, so it is equal to absolute value of x plus 2, and g of x is equal to absolute value of x. So these are my two functions. We already know how to sketch the graph, and again I'm repeating myself again. You have to sketch the graph precisely. We know that this function is like transforming or translating or moving, shifting our parent function 2 units to the left, so our vertex is gonna be in a -2 and the 0 with these coordinates, and it's gonna pass through this point as the slope is 1. So the graph of the first function should, and it looks like this. So y is equal absolute value of x plus 2. This is our first function, and the second function is the parent function of the absolute of the absolute value of the absolute values functions. And as you can see, again, let me just put the name to this function so that we really know that line is representing this function. And if you have a look on the graph on the graphs of these functions, you should now realize that these two lines are parallel and they will never intersect. So the only solution is here, and if we would really sketch the graph precisely, then we will find out that our solution is one element set of number -1. So this is the solution found graphically. Now, as we have the function with, or the equation with two absolute values, you can still find the solution by doing the algebraical stuff I did before in the previous example or in the previous video. But now, more effective way, I guess, in my opinion, and especially if you will have like 3 or 4, maybe more absolute values in the equation, is to find or use the procedure like to find the 0 points of both expressions with absolute values, which in our case are the points x is equal -2 and x is equal to 0. How we find these 0 points is very easy, and I was already explaining. You simply look for the solution of this equation, so you really look just for the information when this expression is equal to 0, and as you can really find it easily, you just don't need to solve these, and you do it by head. And the second one comes from the absolute value of x, and this is equal, x is equal to 0 is quite clear. So these are my 2 0 points. The next step you are asked to do, but this step can be forgotten later on, is to sketch the number line so that you realize that these two numbers split all the real numbers into 3 intervals. Now, based on this information, you just sketch the table to find what is the expression representing the absolute value on each interval. So let me do it. The first interval is from -infinity to -2, and the second one is from -2 to 0, and the next one is from 0 to the infinity. Okay, now as I was explaining already, you just take any number from interval from -infinity to -2. So for example, you take -10, you just fill in and ask yourself if the value of -10 plus 2, okay, because you take this expression, is positive or negative number. In this case it is the negative number, that's why the absolute value will be represented like with the opposite expression, which is -x -2. Now again you take, for example, -1, and you ask yourself, -1 plus 2 is what kind of number? It's positive number. That it means that the absolute value will be represented with the expression which is in the absolute value. And now the same applies for the last interval. You do the same procedure for absolute value of x, and as we already know, for negative numbers it is -x. We are still on negative numbers, so it's gonna be -x, and when we are on the interval from 0 to infinity, it's gonna be x, because for positive numbers the expression is represented by x, or the absolute value. Now you just simply read all the information from the table to do the next steps. So it means for each x from the interval -infinity to -2, our equation, let me just take our equation, and yeah, we do it with this one so that you can see what we are doing. The table, the equation is gonna be here. Okay, so we are solving now this equation for x's from this interval, and our equation will be, you take the first cell from the second row and second column, but this is the first cell. you take basically both these cells, and you will become to the equation negative x minus 2 is equal to minus x, or negative x if you want to. Now these x's will cancel each other, and it would mean that negative 2 is equal to 0. As you can see, this is again false statement, and it means that the set of the solutions for x's being from this interval is empty set. Then you solve the equation for x from the interval from 2 to 0, and it would be, you now take the second column or these expressions, and the equation will become like x plus 2 is equal to negative x, which is simple to solve. This means 2x is equal to negative 2, and x is then equal to negative 1. Okay, this statement is true, everything is fine. So our second set is one element set, number negative 1. Okay, and the last step you take is x is from 0 to the infinity, which means you again take the last two cells from the last column, and it will be x, sorry, let me change to the black color, x plus 2 is equal to x, which again means you will come to the equation 0 is equal to negative 2, which is again false statement, and it means that the K3 is again equal to the empty set. Okay, so this is our last solution. And now again, please keep in mind that the result is the union of these three sets. Let me just have the capital letter as we denote sets with the capital letters, union K3, and in this case it's just K2, which is set of negative 1. So this is our solution. What I said I'm gonna denote is that if you get the result of your equation and the result is negative 1, you have to have a look if this number is from the interval you are calculating with, which basically is not, and I am not sure what happened here. X plus 2, yes, is equal to negative x. 2x plus 2 is equal to 0. Yeah, okay, I know where the mistake is. I'm sorry. This is really important, and that's why, okay, this is good, and that's why I am stressing this information, because it's important. You really have to have a look if this number is part of this interval, and if you think about it, I made the mistake, and you really have to start thinking what happened, what I did right now, and I'm pretty sure maybe you found the mistake already when I was calculating, but if this would happen, that this number is not from this interval, that it cannot be the solution of our equation, but as we already know, it is the solution. We have to find out or think about the problem, and the problem is really clear. Our interval is not from the negative infinity to 2, but to negative 2, okay? So this is the problem where I made the mistake. So we are working with these intervals. And then, of course, negative 1 is from the interval negative 2 to 0, so we are fine here. I'm sorry for this, but this is what is happening during your calculations, and I'm glad I made the mistake, because I could also more precisely explain why it is important to have a look at what is happening and why you have to check if the result of the equation is part of the interval. And one more conclusion, as we found out also algebraically, the solution is only one, and it is happening only really on the interval from -2 to 0, because this is the only interval where these two functions intercept, because again, as I was explaining in the previous examples, this is the line representing my f of x, and this is the line representing my g of x, and as they are also parallel, they will never intersect. The only interval where these two functions intersect is from -2 to 0. Okay, I think everything is clear now, and basically I'll send you some homework where you will be calculating mainly the absolute value equations with 2 or 3 absolute values equations, and if you are asked to solve it algebraically, please use the procedure I have shown you here. But this procedure, if you think about it, is more or less the same as we did when we were sketching the graph of piecewise functions or absolute value functions, where at least 2 absolute values were included. Okay, so thanks for watching, and see you and hear me during our next video. Bye bye.